So for this set of notes, I'm actually going to create 3 little videos. So we talked about the families in class before, and there were 3 families: the pi over 6, the pi over 3, and the pi over 4 families. This first video is just going to be on the pi over 6 and the pi over 3. I'm going to do them together because they're very similar, and you'll see their values are almost identical. And then I'll do the second video on the pi over 4 family, and then the last video will just be some practice on how we do these actual values. Okay, so the first thing I'm going to do is just show you the special right triangles. Now, you probably learned these special right triangles back in academic geometry, but it's been a while, so this should just a little refresher. If I have an equilateral triangle, meaning all sides are the same and all angles are the same, we know that each angle would be 60 degrees, because if it adds up to 180, if we divide by 3, they'll all have to be 60. Now, if I would cut this in half, because I want to create a special right triangle, so I'm going to cut this in half, which creates a right angle on both sides, but it would also cut this angle in half, so this is going to create your 30, 60, 90 triangle. 30, 60, 90. And the sides of this triangle are always going to be in the same proportions. And again, this is probably what you learned in academic geometry. So the side that's across from 30, let's say that's 1. Whatever this happens to be, the hypotenuse is double that. So if this side was 5, this side's going to be 10. And then this side is a factor of square root of 3. So again, if this side was 5, this one would be 10, and this would be 5 square roots of 3. Now, in academic geometry, you had variables here. Your teacher, depending on what method they used, could have had x's here, and don't write this down because I'm going to erase them in just a moment. Or, instead of having x's, maybe they had a's. This is your A triangle. Or maybe b's. Again, depending on what teacher you had, you might have had some variables there. Now, those variables still do exist. Like I said, if b was 5, then this side would be 5, and this side would be 10, and this side would be 5 square roots of 3. But in trig, we don't have to worry about those letters. And the reason why is because we're going to be doing SOHCAHTOA. So all of our answers are going to be fractions. So let's say you had the sine of 60. You would get this over this, opposite over hypotenuse, so those x's or those b's would always cancel. So since we're using SOHCAHTOA with fractions, those variables are not necessary. They're always going to divide out. Okay? So the reason why we're doing the pi over 6 and the pi over 3 families together is because they both come from this triangle. Remember, 30 degrees is equal to pi over 6, and 60 degrees is equal to pi over 3. Okay, so both families reside in this triangle. So that's why we're going to do them together. So we're going to skip the second slide here. That's for the pi over 4 family. So I'll do that in the second video. So we're going to go down to here to the pi over 6 family. Okay, this is our 30 degrees, our pi over 6 family. So since it's pi over 6, that's the angle that's going to be our reference angle. That's the angle that we're going to put down here by the origin as our reference angle. And of course, these are 90-degree triangles. Okay, now I'm going to take the same exact triangle that we did on the first slide and put the values here. So if it's just oriented different. So if I go back and look, here's the pi over 6. So now I'm just orienting it in the first quadrant. So if I put this down there, this side is still 1 is still across from the pi over 6. 2 is still the hypotenuse, and the adjacent side is still square root of 3. So again, I've taken the same 3 values from the first slide, my special right triangle. I've just oriented it in the first quadrant. So I can see that my x value is square root of 3. My y value is 1. And my r value is 2. Okay, so remember our x, y's, and r's. Sine is y over r, cosine is x over r, and tangent is y over x. Now there's another way to think about this. There's really two methods for you to be able to come up with these values. I used to only teach one method. This method that I wrote down already, this is the only method that I taught. Okay, but Mrs. Faust teaches the other method. So I wanted to teach you both so that you could decide what you want to do. And usually it's split pretty evenly, 50-50. Okay, but if you memorize this triangle here, you can always use SOHCAHTOA. And you can say opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. If you want to think about this as being in the unit circle, which means my radius must be 1. Okay, well think about what I just did. If I change my radius from 2 to 1, okay, they have to stay in the same proportion. So if I divide all of these values by 2, the triangle will stay in the same proportion, but I'll have a radius of 1. So this side becomes square root of 3 over 2, and this side becomes 1/2. So now I can think this is my point, square root of 3 over 2, 1/2. So now my x value is square root of 3 over 2, my y value is 1/2, and my radius is 1. Okay? Some students think that this is easier because the radius is 1, so you don't really have to worry about that. You can just think about x, y, and y over x for sine, cosine, and tangent. This way is better for people who like SOHCAHTOA. And they always remember the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay? Again, it's totally up to you what you want to memorize. Okay? But either way, when I get to here, okay, I should be able to figure out my 6 values. The sine of pi over 6 is going to be 1/2. Again, if I'm looking here, sine opposite over hypotenuse, 1/2, or you could think about it as y over r, 1/2, or you could think about it as y, 1/2 over r is 1. It's still 1/2. Now, right now, you might be thinking, oh my gosh, I'm totally confused. I have no idea. I don't know what method I like. I don't understand either method. I don't know what I'm doing. That's okay. All right, we're just starting out. So if you don't know what method you like yet, that's totally okay. The more you get going, the more you'll see which method you like better. So cosine is going to be adjacent over hypotenuse, or x over r, and tangent is going to be y over x, or opposite over adjacent. Okay? Now, I have just a little tiny bit of bad news. When you are doing the unit circle values, which we are doing, you have to rationalize. I know up until this point this year, you have not had to rationalize, and you could leave the square root in the denominator, but for these, we can't do that. And I'll explain why in just a moment, but let's do the rationalization first. So this is going to end up being square root of 3 over 3. So for these values, you can't leave a square root in the denominator. And the reason why is because these are universal values. Like I said, when you go to calculus, they're going to expect you to know these values, and universally, they will want you to know that tangent of pi over 6 is square root of 3 over 3. They won't want you to say 1 over the square root of 3. Okay, so just for these unit circle values, we do have to rationalize. Okay, and now our reciprocals. So 2 over 1 is just 2. Now 2 over the square root of 3, I have to rationalize. So I have to get the square root out of that denominator. And then my cotangent is just going to be square root of 3. Because I'm taking the reciprocal of this right here. So just square root of 3 over 1. Okay, so those are my values. Okay, now, those are the values for the whole family. I know that I drew my triangle in quadrant 1, but if I drew this triangle in quadrant 2, it's going to be the same thing. Sine is still y over r, whether we're in quadrant 3 or 4 or whatever. So all of those family angles that we did in class on Wednesday, or on Tuesday, or on Thursday, whenever you had class, and we did the angle families, any angle that's in this family, the sine is going to be 1/2. Okay, now we will have to deal with all students take calculus. We'll do that in the third video for this. Okay, but for now, the value is always going to be 1/2 for the whole family. Okay, now let's go to the pi over 3 family. So the pi over 3 family, now pi over 3 is the angle that's here in my triangle. Okay, so now I'm just orienting the triangle a little bit different. So it's the same triangle with the same values, but now square root of 3 is here, 1 is here, and 2 is still my hypotenuse. It's still the same triangle. It's still my 30, 60, 90. If you go way back to the beginning, that one's probably a better one to look at. So across from square root of 3, across from pi over 3, whoa. Let's not do that. I don't know what that is. Nope. Okay. Across from square root of 3 is pi over 3. Adjacent is 1, and the hypotenuse is still 2. So again, I'm just orienting the triangle differently. Okay. So now, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Again, if you are a SOHCAHTOA person, you can just memorize that triangle. Or you can think of x being 1, y is square root of 3, and r is 2. Now again, if I want this to be in the unit circle, I can divide everything by 2. And so now here's the point. 1/2 square root of 3 over 2. So my x value is 1/2. My y value is square root of 3 over 2. And r is 1. So either way, when I go and find the sine of pi over 3, the sine of pi over 3 is going to be square root of 3 over 2, no matter what way you look at it, whether you do SOHCAHTOA or whether you do x, y, and r. Cosine is now 1/2, and tangent is a square root of 3. Notice that these values are super similar to the pi over 6 family. And that's because, again, they're from the same triangle. So really, all we've done is we've switched the adjacent and opposite side. The hypotenuse is the same, because we're still in the same triangle. Just we've oriented it differently, so now the opposite and the adjacent switch. Or you can think about it as being the x and the y switch, because they do. Okay, so whether you're an x, y, r person or a SOHCAHTOA person, it's just the O and the A switch, or the x and the y switch. So I can see from these values to these values, these have switched, which means these have switched, and then your cotangent and tangent have switched. Okay, so it's really just remembering which values go with which family. The pi over 6, the pi over 3. Now again, you will have to have these memorized. Okay, these values are not going away. We will have to find them for the rest of the year. So you need to come up with your best way to memorize them. Either memorize the triangles and do SOHCAHTOA, memorize your x, y, and r values, and you could memorize either set of values. These ones or these ones. You can memorize the point. Okay, a lot of students just like to remember the 3 points. The point for pi over 3, the point for pi over 6, and the point for pi over 4. They like to do that method. That's totally fine. And then r is 1, so you don't really need to worry about r if you do this method. Or, I've even had students straight up memorize those values. They just do flashcards and they just remember, hey, the sine of pi over 3 is square root of 3 over 2. Okay, they just come up with ways for their brain to remember them. Okay? Again, these values are super important. We're going to use them for the rest of the year. And in calculus, I expect my students to know these. So again, they should walk in the door knowing that the cosine of pi over 3 is 1/2. Okay, now, the last thing to say before I stop and start the next video is, remember, we are dealing with radians now, but this also deals with degrees. This, if you remember when we did our angle families, I always called the angle family pi over 3. Even if it ended up being 60 degrees or 120 degrees, those are still part of the pi over 3 family. So that's why these values I put in only radians, because we're naming the families by the radian value, not the degree value, because degrees are going away very shortly. Okay? So, if you want to watch, the next video is going to be just on the pi over 4 family, so it'll be a lot shorter than this video was.